Science is about understanding the physical world and answering the question of how things happen. Religion, it seems to me, is concerned with a different set of questions, namely the questions of why. Is there a meaning and purpose in what's going on? So I don't think that science and religion are competitors in conflict with each other. They are, in fact, complementary. We need both to understand the world in which we live.
Radio telescopes are giant aerials linked together electronically and pointing into outer space. Day and night they listen into the radio waves that come from galaxies in the furthest parts of the universe. We live in a strange universe. There are 100 billion star galaxies, and each star galaxy is made up of 100 billion stars. Just one of these stars is our sun. The universe existed for 11,000 million years before life appeared on our planet. The sun for about 1 billion. Scientists, philosophers and theologians have long argued whether humankind is the fruit of mere chance or whether there is a grand design behind our existence. In the past, people have pointed out that the universe seems ludicrously over-designed if its only function was to produce a carbon-based life form like ourselves to inhabit a single planet. The universe seemed bigger and older and more complicated than could possibly be necessary. But nowadays, there's a wide agreement among scientists that given the laws of physics that operate in our universe, all those billions of stars and billions of years are necessary before one human being could exist. That fact is one of many uncovered within the last 30 years, which leads to the view that our world is not just any old world, but one exquisitely designed to lead up to the appearance of intelligent life. The only form of which we know is the human race. Experiments with cathode ray tubes and Wilson's invention of the cloud chamber led to the most exciting work in the early part of this century, when Rutherford and others learned with their particle accelerators about the structure of the atom. In the ancient world, science and religion were not separate pursuits, but were together unified in humanity's search for truth. John Polkinghorne, former professor of theoretical physics and currently president of Queen's College, is one man who brings the two disciplines together in his work.
When I was at school, I was quite clever at mathematics, and I came up to Cambridge to read mathematics. And while I was here, I got interested in the remarkable way in which one could use mathematics to understand the physical world. And that led me into theoretical physics. And I was a university teacher for over 25 years. Eventually, I was a professor here in Cambridge and ran a large research group, which I enjoyed very much and felt to be a Christian vocation, in fact, to use my talents in that way. So when I began to think that I would do something other than physics, it was natural to think about the possibility of serving the church in some way. And the idea of ordination came to me, and fortunately also to my wife, quite quickly over a period of a few months. It was very strange becoming a student again at about the age of 50 and listening to lectures rather than giving them, but I enjoyed that. And then I went off into parish life, to learn how to do the trade, and I was a curate in Bristol, and then I was a vicar in Kent for a short while. But I decided that part of my ministry was to write and think about science and religion, and so when I was offered an unsought opportunity to come back into the academic world, first as the Dean of Trinity Hall here in Cambridge, I decided that that was the right thing for me to do, and now I've drifted a little bit further upstream on the Cam to Queen's College, where I'm now its president.
The President's quarters in Queen's College date back to the 16th century. It was in these ancient and gracious surroundings that I asked John Polkinghorne about the age-old tensions between science and religion.
I think modern science, 20th century science, is more hospitable, encouraging to a religious point of view than it might have seemed at some previous periods. There are various reasons for that. One is that we realise that the world isn't mechanical, and therefore it's a world more interesting and open to God's action within it, it seems to me. One is that we've come to realise how marvellous the world is and how delicately balanced and structured it is. And the more you realise that, the more you seem to see signs of mind in nature, and the more you seem to feel that there's something going on here, which is more than science can talk about. The more you're driven to the idea of an intelligence behind the physical universe. 20th century science is very encouraging to that, I think.
Scientists generally agree that all the matter and energy in the universe began as a hot, dense concentration of space-time smaller than anything we can imagine, which exploded and expanded to form the entire universe, and indeed is still expanding. Some scientists believe the universe possesses no conserved qualities other than those of positive and negative fields of force, which average out precisely to zero. This brings us very close in scientific terms to the idea of creation out of nothing. In 1964, the early generation of radio telescopes first detected the feeble background radiation left over after this primeval explosion, known as the Big Bang. Today, the radio telescope here in Cambridge can detect objects 12 billion light-years away. But this also means one can examine objects as they were 12 billion years ago, 3/4 of the way back in time to the Big Bang.
The history of the universe is an astonishing story, because the universe as we know it started 15 billion years ago, and it started very, very simple. It was just an expanding ball of energy, and you can't get a physical system that's much simpler than that. And of course, over that 15 billion year history, it's become very rich and varied. It contains such interesting consequences as you and me. So the history of the universe is a history of initial simplicity giving rise to great complexity. It's a story of great fruitfulness. One of the most interesting things we've come to realize in the last few years is that that history of simplicity turning into complexity wouldn't be possible in any old universe. It's only a very special universe, a very finely tuned universe, one might want to say, which is capable of producing men and women. So that, for example, if you were to slightly change the ground rules of our universe, if you were to, for example, make gravity a bit stronger or make other forces of nature different in some way, that fruitful history that produced you and me would have become impossible. That's a very remarkable fact about the world. We live in a universe in a trillion.
The expansion of the universe and the way different kinds of matter came to be, eventually making life possible, are governed by 4 forces, obeying laws which are now known and understood. There is the strong and the weak nuclear force, electromagnetism and gravity. These laws are the same in all places and all times, in the microcosm of the atom and the macrocosm of outer space. If one modifies any of these laws by even the tiniest amount and work out with computers the consequence, then life as we know it or can conceive of it would have been impossible. If, after the Big Bang, the universe expanded any faster than it did, gravity would not have been able to form the stars. If it expanded any slower, it would have come to a halt and collapsed before life could have existed. The speed of expansion had to be accurate to a parameter of 1 part in 10 to the power of -60. If the so-called weak force was slightly stronger, then supernova explosions would be impossible. Without supernovae, there would never be elements heavier than iron, and all the elements heavier than helium would be locked up in dead stars. So again, life would have been impossible.
As the universe's history unrolled, all sorts of things had to happen. For example, first of all, stars had to form. The universe had to become a bit clumpy. And stars were necessary because they make up the elements that are necessary for life. You can't have life with just hydrogen and helium, which were the simple elements there when the universe began. You need things like carbon and iron. And all those are made inside stars. Every atom of carbon inside our bodies was once inside a star, so that we're all made from the ashes of dead stars.
The first element in the universe was the simplest form of matter, hydrogen. Some of this gas came together to form stars like our Sun. Within the hot interior of the Sun, hydrogen atoms are knocked together to make the next heaviest element, helium, releasing energy to heat the Earth. In larger stars, the pressure is even greater, and helium atoms are knocked together to form heavier elements, all the way up to iron. But to make elements heavier than iron, some of which are necessary for human life, even stronger forces are required. As the hydrogen fuel runs out on a star, the whole body expands and cools into what's called a red giant. In about 5 billion years, our Sun too will become a red giant. As a very large star cools further, it collapses in on itself and creates forces so strong that the lighter elements are knocked together to form the heavier ones like zinc and iodine, both necessary for human growth and reproduction. Supernova explosion, which immediately follows, scatters the new elements previously locked up in the stars. More energy is released in 1 second than the Sun radiates in its whole lifetime. The star, known as Cassiopeia A, exploded in 1680 and scattered material out over an area now 13 light-years across. On average, one supernova occurs every century. Scientists are still busy analysing the data from the last one, observed in 1987.
It's a very remarkable fact that we can understand the physical world, not only at the everyday level, where of course we would expect to understand it, because if we didn't, we wouldn't survive, but even when we explore parts of the physical world that are very different from the everyday. For example, the quantum world, the subatomic world, where if you know where something is, you don't know what it's doing. If you know what it's doing, you don't know where it is. That world is unpicturable, but is not unintelligible. And it turns out it's mathematics which is the key to understanding it. One looks for equations that are beautiful and elegant. In fact, the greatest theoretical physicist I ever knew was somebody called Paul Dirac, who was a professor here in Cambridge. And he once said it was more important to have beauty in your equations than to have them fit experiment. But that didn't mean that it didn't matter whether they fit the experiment, but if they didn't, maybe that was because you hadn't calculated it right, or maybe the experiments were wrong. But if the equations were ugly, that was an irredeemable feature, and they just couldn't be right.
Computer calculations in 1980 showed that shock waves inside a collapsing star were not enough to bring about a supernova explosion. It could only happen if small particles called neutrinos were to interact in a precise way with other particles. The value had to be just right, or the supernova wouldn't explode. Supernova 1987 provided a burst of neutrinos. Their numbers and their energy matched exactly what the computer model said they should have been.
There does seem to be a marvellous fittingness between our minds, the reason within, and the structure of the physical world without. The two fit together in a way that is quite surprising and I think very significant. Einstein once said the only incomprehensible thing about the universe is that it is comprehensible. Why can we understand it so well?
Albert Einstein predicted on the basis of equations worked out in his mind, and sometimes scribbled on the back of an envelope, that certain things must be true. His equations predicted the existence of black holes, that matter and energy were interchangeable according to the equation E = mc squared, that light is bent by gravity, and that the universe must be expanding. At the time, everyone thought that the universe was static rather than expanding, so Einstein wasted a lot of time going over and over his calculations, thinking he must have made a mistake.
The fact that we can understand the universe so well does suggest to me that there is a common reason, or if I would want to say a common mind, behind both our mental experience and the structure of the world in which we live. And of course, as a Christian believer, I believe that that is exactly what there is, that we see the mind of the Creator in the rational beauty of his creation.
John Polkinghorne's life work has been more to do with the world of atomic particles than the world of supernovae. One of his academic predecessors, Ernest Rutherford, discovered that atoms are made of protons and electrons by shooting them at each other and collecting the bits. He described it as the most incredible thing he had ever come across. It was almost as incredible, he said, as if you fired a 15-inch cannon shell at a piece of tissue paper and it came back and hit you.
About 40 years ago, looking at the smallest bits of matter, we discovered that these protons and neutrons are themselves made up of even smaller particles, which we call the quarks, which is a quotation from James Joyce, actually, and the particles that make them stick together, which I'm afraid we call gluons in a rather sort of terrible, jokey way. So matter is very complicated and structured and has different levels. And there's no particular reason to think that we've got to the bottom of it all with the quarks and gluons. Maybe they themselves are made of something yet more fundamental. So there seems a sort of inexhaustible richness even in the structure of just the material world.
The first particle accelerators made in Cambridge were simple affairs compared to today's accelerators. This one is the largest research instrument ever built, a circular underground tunnel 27 kilometers in circumference, built astride the Franco-Swiss border. 2,000 scientists from 26 countries work here. Electrons and positrons are accelerated to energies of 45,000 million volts and travel at speeds close to the speed of light. The particles go round the accelerator in a vacuumed aluminium tube about 10,000 times a second and are then brought into collision in large detectors.
We found that when we take things apart, the universe, so to speak, fights back. Even the atomic world can't be described simply atomistically in terms of little bits. Because, for example, we've discovered, most astonishing discovery, that if you have two electrons, once they've interacted with each other, then they will retain a power to influence each other, however far they separate. If one stays behind here, the other goes, as we say, beyond the moon. If I do something to the one that stays here, it will have an immediate effect on the one beyond the moon. That's a most astonishing discovery, which has been verified experimentally, not by going beyond the moon, but by equivalent experiments. And so there is a sort of togetherness in separation in the physical world that's very strange and surprising, but part of the rich story.
The diameter of an atomic nucleus measures about 1/1000th of a millimeter. Delving into the structure of matter, scientists work with particles they can never see, acting in ways they can scarcely even imagine.
People think that science is just sort of skeptical all the time and questions everything. Now, in fact, you wouldn't get anywhere in science if you were questioning everything. You have to have some basis of belief. You have to commit yourself that the world is likely to be this way, and then go on to find out whether it is. Now, you may have to correct that belief. You may find that what you first thought wasn't quite right. But if you were simply skeptical, you would never make any progress at all. So, in an interesting way, science requires commitment, faith, belief to a particular point of view, which you then measure against experience and perhaps adjust in the light of experience. Now, actually, I think religion is exactly the same. Religion doesn't involve shutting your eyes and gritting your teeth and believing the impossible. It means that you learn from the scriptures and from the experience of the church what God is like and how he has made himself known, particularly in our Lord Jesus Christ. And then you measure that against your experience. So I think in that sense, science and religion are not so different. In fact, I think they're cousins under the skin.
Our sun has had a profound influence on our planet over its 4.6 billion year history. Our world was a violent, noxious place of poison oceans and lightning storms. Under the benign rays of the sun, it was mysteriously transformed after 4 billion years into a world inhabited by complex, reproducing organic molecules we call life.
The universe is 15 billion years old, and we've been around for just a few 100,000 years at the most. We emerge, however, as something entirely new in the history of the universe. We obviously arose from primitive ancestors. We arose from the animal world. But we have qualities that the animal world doesn't have. We are self-conscious, we know about ourselves, and I want to say also, we are worshipping beings, we know about God. So we represent something really new in the history of the universe. I think that our self-consciousness, that we're aware not only of what's happening, but that we can reflect upon that not only that we die, but that we know we're going to die, which I think animals don't know, that is one of the things that makes us different.
Wonderful and all as is the universe disclosed by the mighty telescopes, the most complicated creation of all is 6 inches behind the eyepiece.
One of the most surprising things is that how rapidly the human brain grew. The human brain is immensely complicated. It's the most elaborate physical system we've ever encountered in our exploration of the universe. And it evolved very, very quickly in just a few 100,000 years, which may sound a long time, but in terms of the history of evolution, it's just a few minutes, really. And that's very striking. I don't think we understand, really, how that evolution came about quite so quickly. It's a bit of a puzzle, really.
It is, of course, possible to imagine any number of other kinds of universe, where the different controlling forces, like gravity or electromagnetism, might be stronger or weaker than in our own.
When we think how special the universe is, that seems to demand an explanation. And I think there are really two ways of explaining it. You could either say, well, perhaps there are lots of different universes, and we just happen to live in the one that happens to be just right to produce humankind. That would be one explanation. Now, that's a guess, but it's not a scientific guess, because scientifically we only have reason to know about the universe that we can explore and which we inhabit. And I think it's a much better guess myself that there is in fact only one universe, but which is the way it is in its very delicate and fruitful balance, because it is not any old world, but it is a creation which God has endowed with just those properties that will make it fruitful.
Both science and the Bible seem to agree that our world will have an apocalyptic end. But the destiny of the human race transcends questions of physical life and death. Moral issues are involved, whether good will triumph or evil.
I think that the problem of evil is the most difficult problem for belief. It keeps more people back from belief, I think, than anything else, and it's the greatest worry for those of us who are believers. I think that the key to understanding it, really, is that God is not a sort of puppet master who pulls every string and makes everything happen according to his will. Nor is he, of course, indifferent, just letting things happen and take their course. He interacts with the world, but he has given to his creation a freedom to be itself. So he allows us to make our choices and sometimes to do terrible things, and he allows, if you like, the whole universe to do its thing as well. When an earthquake takes place, it's not God's will that lots of people should be killed, but he allows the earth's rocks to behave in a way that's natural for them. So I believe that God neither wills the act of a murderer nor the incidence of a cancer, but he allows both to happen in a world to which he's given its own true freedom.
In recent times, new technologies have vastly increased the store of human knowledge. Yet science as we know it is no older than a few mere ticks of the clock that measures cosmic time.
People sometimes think that in the scientific age, religion has got to be reasonable. Now, if that means it's got to have motivation, of course I entirely agree with that. But if it means it's simply got to be reduced to common sense, what anyone can accept just straight away, I'm not persuaded by that at all. Science isn't like that. Science is full of surprises. The most odd things happen. The quantum world is entirely different from the everyday world. But it has its own rich structure and understanding. And it seems to me that actually Christian theology is like that too. In terms of everyday experience, how can God be three persons and yet one God? But there is, I think, something satisfying and profound in the Christian doctrine of the Trinity. And it arises, of course, from human experience, that we know God as God above us, God our Father, God made known in human terms in Jesus Christ, God alongside us, and God at work in our lives, the Holy Spirit within us. So the doctrine of the Trinity is both exciting and also based on experience.
Religion and science have not always had an easy relationship. Galileo taught that the earth moved around the sun and not vice versa, as the Bible seemed to teach. In 1633, the Holy Inquisition forced him to retract this supposed heresy. Eventually, the Vatican did apologise for condemning him 337 years after his death.
This is a sort of popular picture that somehow or other science and religion are at each other's throats. But in fact, if you look at the history of science, that isn't so at all. Science in its modern form started in Western Europe in the 16th, 17th centuries, and the people who got it going were mostly people, religious people. Most of the first fellows of the Royal Society were Puritans. Galileo was a religious man, though he had his problems with the church, of course. Newton was also a deeply religious man, though he was perhaps a little unorthodox in some ways. And people were motivated to look at the physical world because they thought it was God's creation and worth studying. And in fact, that connection between science and religion has persisted. For example, here in Cambridge in the 19th century, we had some very, very great people, Maxwell and Kelvin, and people like that, who are also deeply religious. So the sort of picture that somehow or other you have to be either a scientist or a religious believer is just not true. In fact, I'm both myself.
John Polkinghorne has had an unusual career. Professor of Theoretical Physics, curate in Bristol, vicar in Kent, Dean of Trinity Hall, and finally elected by his fellow academics to the prestigious post of President of Queen's College, Cambridge. It's a career based on two loves, the love of science and the love of God.